So if we are looking at exponential functions, we can model it using this situation as a kind of introduction. So a new disease is turning a city into zombies. Government researchers have determined each zombie creates one additional zombie each day. Disease started with one zombie. How can we use mathematics to represent the number of zombies after each day? So here we have one zombie, and each row that we're going to create is going to represent a different day that we can create into mathematics, but just to explain the process. So from this one zombie, after 1 day, or at 0 days, there's only one, and after 1 day, there will be him, and he will create another zombie. From here, this zombie will then create, on the next day, himself will be there, and another zombie. This one will also have himself on day 2, and also create another zombie. And if we continue this for a 3rd day, you can see that this guy will create one more, or will have himself and create an additional zombie. This guy here will have himself and another zombie on day 3. This guy will continue into day 3 and also create another zombie. And this one over here, I'm going to slide him over, will have himself, but also include another zombie. So we can actually break this diagram into an informational table. So here we've created a quick table that represents the number of days, starting with 0 days, and then 1 day, 2 days, and 3 days, and then we're going to fill in the information showing the number of zombies. So on the first day, or 0 days, that was the first day, or the 0 days, we started with just one zombie. After 1 day, there was himself, but he created one additional zombie for a total of 2. On the 2nd day, those 2 zombies from day 1 created 2 additional zombies for a total of 4 zombies. And after day 3, those 4 zombies created an additional zombie for a total of 8. Now, if we want to mathematically break this down into something where we could predict after 100 days how many zombies we would have, we need to put this in terms of a function. In this case, we're going to let the number of days be represented by the variable x. In analyzing the information we have, we can actually set up a function. So if you think about this, 1 can actually be represented by 2 to the 0 power. Anything to the 0 power being 1. The number of zombies on day 1 can actually be represented by 2 to the 1 power. And if we think about 4 being the same thing as 2 times 2, which can be written as 2 to the 2nd power, and 8 can actually be written as 2 times 2 times 2, which gives us 2 to the 3rd power. And what you might see here is that the number of days is actually the number represented in the 0 power with the base number of 2. Same thing with the 1 to the exponent. Number of days 2 is the power, and then 3 is also the exponential power. So our function here uses the base of every time is 2, but the number of days is actually the power in the exponent. And this is an example of how we can represent this model using exponential functions. An exponential function is basically this idea that anything that has a variable in the power. This situation can even be modeled further if we take the information in our table and put it into a graph. And in this graph, we can use the number of zombies, where x will represent the number of days and y will be representing the number of zombies. That on day 1, or 0 days, there was only 1 zombie. So we can graph that point, 0, 1. After 1 day, there was a total of 2 zombies. After 2 days, we had a total of 4 zombies. And after 3 days, we had a total of 8 zombies. And you can kind of see that this is not necessarily a straight line, but it's actually better represented as what will be an exponential looking graph where it will continue like so and has an increase and decrease. So this is why the importance of exponentials, it is important to study exponentials, because different situations that multiply by a common factor, multiple, or rate can be modeled using exponential functions.